morning, students. In this session, we are going to see what are scheduling algorithms. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. Coming to process scheduling algorithms, we have 4 different process scheduling algorithms. One is FCFS, and second one is SJF, and third one is priority, and fourth one is round robin. So when you consider these algorithms, we are dividing these into 2 types. One is preemptive and the other one is non-preemptive. So whenever we consider FCFS, we will see in this session what is FCFS and SJF. FCFS, this is non-preemptive, as the process which is trying to allocate first will be executed first. Okay, so in the FCFS, as the name indicates, it is first come first served scheduling algorithm. So every scheduling algorithm will be taking 2 inputs. One will be the number of processes, a different number of processes. So your number of processes is 3. That is, and the burst time is P1 is burst time is 24. This is CPU burst. Okay, and P2 is 3 and P3 is 3. And there is a process arriving. So what is a Gantt chart for this will be? So Gantt chart is something like this rectangular box where you have to allocate the process according to the scheduling. So first come first serve is according to the process which has been arrived the ready queue first. So according to the queue, P1, P2, P3 is the arriving order it has been given. So P1 will be allocated the CPU first at 0th millisecond, and the burst time for CPU to complete the process P1 is 24. This is the burst time. So how much time the P1 is turnaround time for P1 is 24. Okay. Then after P1, what is the second one? P2. Now you have to allocate P2, and the P2's burst time is 3. Therefore, this 3 milliseconds. Now 24 plus 3 is 27. So the turnaround time for this P2 will be 27 milliseconds. And if you take P3, in the next order it is P3. Now this is a ready queue. Okay, P1. Now first P1 is allocated, next P2 is allocated, next P3 is allocated. Now when P3 is allocated, what is the burst time? 3 milliseconds. Now this 3 milliseconds is considered, and here 27 plus 3 is 30. Now whatever the values you have at the initial position of a process, the Gantt chart represents this as a waiting time. And whatever you have towards the right hand side of a process, and these are nothing but the turnaround time. Suppose if you wanted to draw a diagram or represent within terms of a table, then the process P1 burst time is 24, and let us calculate the waiting time and turnaround time. Waiting time is time taken for the process to wait for its job to get allocated to the processor. Now what is the waiting time for P1? 0. What is the waiting time for P2? 24 milliseconds, because 24 milliseconds is the turnaround time for the process P1 until unless this 24 is getting executed, P1 will be waiting. So 24 will be the waiting state. Then P3, for P3, 27 will be the waiting state, and coming to the turnaround time, this is burst time plus waiting time is the turnaround time. 24 plus 0, 24, 3 plus 24 is 27, 3 plus 27 is 30. So this will be the burst time, turnaround time. Now, as we have seen the Gantt chart, the waiting time for P0 will be the 0 millisecond, and for P2 it is 24 millisecond, and for P3 it is 27 milliseconds. Now average waiting time can be calculated by all these waiting time whatever we have plus divided by the number of processes. So number of processes are 3. So what is that you calculate? 0 plus 24 plus 27 divided by 3. So it is around 70. Similarly, how do you calculate the average turnaround time? Is average turnaround time is equals to 24 plus 27 plus 30 divided by 3. So that will be the average waiting time. So for any process to execute, if we are considering the first come first serve, that means whatever the process are in the order, that order in the ready queue will be allocated the CPU in the same order. So P1, P2 and P3 with respective burst times. Then so this is a same process. If you have process are arriving in this order P2, P3 and P1, okay, and the burst times are given here and the Gantt chart is given 0, P2 is having 3, so let me write it here. For the same 20, P1 is 24, P2 is 3, P3 is 3. Now what is the order that has arrived? FCFS will take according to the order. P2. P2 has been arrived first, then P3, then P1. So this is the sequence order. Now what is their burst time? Burst time of P2 is 3, burst times of P3 is 3, burst time of P1 is 24. Now if in this case, if you see what is the waiting time? So the waiting time of P1. So here you have to see the Gantt chart. P2 has been arrived first. This is the ready queue. P2 has arrived first and the burst time is 3. So it has executed for 3 milliseconds. And P3 is also 3 and 3 plus 3 it is 6. And P1 it is 24. So 6 plus 24 it is 30. Now what is the waiting time? The waiting time of P2 will be 0. And waiting time of P3 will be 3. Waiting time of P1 will be 6. Now that is given here. P1 is 6, P2 is 0 and P3 is 3. Now if this is the case, what is the average waiting time here? 6 plus 0 plus 3 divided by 3, you are getting 3. Now much better than the previous case. So in the previous case, what is the average waiting time? 17. But now what is the average waiting time? 3. Because the burst time of a process which is higher is executed later. And the burst time of a process which is executed here is initially it is executed. Okay, P1 is executed first. Therefore, this effect we call it as a convoy effect. Shorter process behind the longer process is nothing but the convoy effect. So these are all the shorter process P2 and P3, but these are executing after P1, then this is increasing the waiting time. But what is the criteria we have seen in the previous session? The waiting time should be minimum, the response time should be minimum, turnaround time should be minimum. So here it is maximizing. So FCFS has one drawback of convoy effect. Convoy effect is that where shorter processes are there behind the longer process. That means you have a process with a larger burst times initially. Okay, so consider one CPU bound and many IO process. If that is the case, then there will be longer waiting time, longer response time. Then we'll move to SJF. SJF is what? Shortest job for scheduling. So whenever you have a CPU burst and the IO burst, this is the cycle that we have seen for every process. And with each process, the length of its next CPU burst, use these lengths to schedule the process with the shortest time. Suppose, I'll tell you with the help of an example. And SGF is optimal, gives minimum average waiting time for the given sets. Average waiting time is minimum when compared to FCFS. Difficulty of this is knowing the length of the next CPU request is difficult here. When it is very dynamically executing, then the lengths are not known. So, knowing the length of each process priorly is the tougher job. And the information should be given by the user. So, we have this example of SJF where we have given a number of processes and the burst times. If you see here, what is the burst time of a process which is very short? So this we have to change the order. This is the question that has been given. Now we are changing the process and their burst times according to the order. Now, which is the burst time is least burst time? P4. So, P4 will be executed for 3 milliseconds first. That is shortest job first. Whatever the process is having a shortest burst time, that is executed first. Next, after this, you have a 6. Now, P1 will be 6, P3 7. Next least is the P8. So, P2 is 8. So, this is the order where whenever you consider SJF, we have to sort in such a way where the burst times of a particular process should be less than the other process. If this is the case, we are drawing for this the Gantt chart. So, what is the first process? P1. So, P1 is executed first for how many milliseconds? 3 milliseconds. Then P2 for 6. So, this will be for 6. So, 3 plus 6, it is 9. Similarly, P3 for 7. So, 9 plus 7, it is 16. Then P2 for 8. 8 plus 16, it is 24. Now, what is the average waiting time if you consider 0 plus? Let me write a waiting time here. So, waiting time for a process P4 is 0 and for the process P1 is 3, process P3 is 9 and process P2 is 16. Just calculate this, you will get 7. So, number of process of 4. So, 3 plus 16 plus 9 plus 0 divided by 4, you get 7. So, the average waiting time for this will be 7. The same process or the same burst times if you consider, and if you do FCFS, then the waiting time will be higher compared to SGF. Okay. So, to avoid convoy effect, what we are doing, all the process which with the least burst times, we are trying to reorder so that we change the sequence and give the CPU allocation for the process which are having the least burst time. Okay, in that way we achieve SJF with the minimum waiting time. And we also have in SJF shortest job first. There are two types. One is non-preemptive and the other one is preemptive. Okay, preemptive and non-preemptive. So, wherever we have discussed till now, this is the example of non-preemption. Non-preemption does not contain any arrival time, simply burst times are given and you are sorting according to the least burst times. Whereas in the preemption, this is a shortest remaining time first, SJF with preemption. The other name for SJF with preemption will be shortest remaining time first. So, now we add the concepts of arrival time and the preemption to the analysis. So, what is that? We have the 4 process, we have the burst times, we also have the arrival times. Now, according to preemption, SJF preemption, we need to draw the Gantt chart. Now, what is Gantt chart is showing here is whatever the process which is having a least burst time, 5. But 4. Are we executing 4 first? 4 means what? P2. Are we executing P2 first? No. Why? At time 0, P1 has been arrived. So, what we are doing? P1 is executing for 1 millisecond. At 1 millisecond, you got P2 with the least burst time. So, what we are doing? We are executing P1 for 1 millisecond. When it is executing for 1 millisecond, the remaining burst time now is 7. At 1 millisecond, what is happening? P2 has been arrived into the ready queue. So, initially there is only P1. After 1 millisecond, you have P2 also. Then, after 1 millisecond, P2 has to execute its process for 4 milliseconds. Because at 2 milliseconds, you have 9 which is higher than these two burst times. So, we will complete P2 completely. So, 4 plus 1, it is 5. Now, what is the next least burst time? So, this has been executed and is becoming 0. Now, next least will be 5. P4 is arrived at 3 milliseconds. Now, it is 5. At time 5, all the processes are in the queue. Now, you have P3 and also P4. But after P2, what is allocating the process which has to be allocated using the SJF? That is P4. Now, after P2, P4 has to allocate, then P1, the remaining burst time, then P3. Okay, this is a ready queue. Now P1 completed, P2 also completed, right? Now next is the P4. Whenever P4 is allocating, what is the P4 burst time? 5. So 5 plus 5 is 10. Okay. Now after P4, what is there? What is left? This P3 and P1 is left. Which among is the least burst time? This also completed 0. 7 and 9. 7 is least. So 7 is in the ready queue. Now P1 is allocated for 7 milliseconds, so that it is 17. 10 plus 7. Okay. Then later on, what has to executed? The remaining process, P3. Only 1 is left. So this also executed. 9 is executing. So 9 plus 17, 26. Now in this way, whenever there is a arrival time given, according to the arrival time, we have to schedule a ready queue. The scheduler and the dispatcher sees which process to allocate the processor. So, according to the arrival times and the least burst time, the processor will allocate it P1 first, then P2, then P4, then P1, then P3. Okay. Now, from this, what we have to do? We have to calculate how do you get average waiting time and the average turnaround time. So, if you see here, average waiting time is of P1 is 10 minus 1. That means what? Let us write a completion time here, turnaround time, then waiting time. So what we have to do, we have to find the completion time. So completion time here for P1 is completed at 17, right? P1 has been completed at 17 milliseconds and P2 has completed at 5 milliseconds and P3 has completed at 26 milliseconds and the completion time of P4 will be 10 milliseconds. Now this will be for P1, P2, P3, P4. Now what is the turnaround time? Okay, turnaround time will be the completion time minus arrival time. 17 minus 0. What is the turnaround time here? 17. Okay. And 17 minus 0 is 17. And here I'll write CT, completion time is equals to, turnaround time is equals to completion time minus arrival time. And waiting time is equals to TAT, turnaround time plus burst time. Okay. Now we have to give what? CT minus AT. Now TAT is 17 minus 0. 5 minus 1, 4, 26 minus 2, 24, 10 minus 3, 7. Now, what is the waiting time for the same process? So, waiting time will be turnaround time plus burst time. 17 plus 8. Please ignore this. Okay, waiting time is turnaround time plus burst time. Turnaround time minus burst time. Sorry. So this I was thinking waiting time is turnaround time minus burst time. Turnaround time is 17. So 17 minus what is the burst time of P1? Burst time is 8. So 8. That means you will get 9. Right? Then waiting time, turnaround time minus burst time. Now, what is the turnaround time? 4. 4 minus, what is the burst time of P2? 4. So, here waiting time is 0. Then, you will have 24 minus burst time. Burst time is 9. Okay, similarly, okay. Then you have as a turnaround time 7 minus burst time is 5. So 2. So this is how we calculate the waiting time. Now average of this will be all this 9, 10, 11, 11 plus 15. So 26. 26 divided by 4. So here you will get around 6.5. So this is the average waiting time for a process and this is how you have to calculate. First thing, you need to draw a Gantt chart clearly by considering the SJF and you have to consider these two formulae. One is turnaround time and waiting time, and you should draw the Gantt chart and get the completion time. Completion time is the time period that has been taken for a process to complete its entire job, because we have taken a preemption. That means we are executing for a fewer time, and again you are giving a chance for the same process to complete its remaining time. So that is why it is named as a shortest remaining time first. Hope you all understood what is SJF without preemption and with preemption. And here you have to calculate the turnaround time using CT minus AT. CT is a completion time, AT is a arrival time. Waiting time is again turnaround time minus burst time. Turnaround time is what we have calculated. So you will have the burst time that is given. So just subtract burst time from the turnaround time, you will get just average of that will be the sum of all the waiting time by the number of bursts. Similarly, here you can average turnaround time will be all this. Okay, 52 divided by 4. So that will be the average waiting time. When you consider SJF, the minimum should be the turnaround time, minimum should be the response time, minimum should be the average waiting time, so that it overcomes the convoy effect. Okay, so to avoid convoy effect, we are extending FCFS into SJF, SJF into again SJF with preemption, and the arrival times are being considered. Okay, hope you all understood. Thank you all.